Alright, so I'm going to go ahead and start going over arc length now. So we finally built our way up to where we're ready to talk about it. And in this case, what I want to do first is remind you real quickly what we're talking about. We're talking about distance, we're talking about length, we're talking about rectifiable curves, which are smooth curves, curves that are continuous and differentiable on the interval. And what we're getting ready to talk about again now is using arc length. So if you were in, say, a geometry or maybe even advanced algebra trig or pre-calculus, one of those other earlier classes, we would have talked about arc length of part of a circle. So we would have actually had, this whole circle here, and we would have said, what's the arc length along this angle measure? And so if you're in geometry, you're going to learn that it's whatever your angle is in degrees divided by 360 degrees, and you're going to multiply that times 2 pi r. Because this is essentially your circumference, and what you're doing is taking a proportion of it. Now, if you're, say, in pre-calculus or even advanced algebra trig, maybe even some of your physics classes, you might talk about arc length as the angle theta in your in radians, and multiply it by r. And that is still going to give you your arc length, but again, we're talking very specifically about circles and not about curves. And so I do want to make sure I point out one other thing. We also tend to use the letter S to represent arc length. That's an important fact we need to know. So the question is, how are we going to have any other curve besides a circle? How are we going to take some curve and find its arc length? How are we going to find the distance between 2 points along a curve? And so this is where calculus comes in. So what we're going to do is we're going to integrate along that interval. Remember, it has to be both continuous and differentiable. It has to be both. We're going to integrate along this interval, and we're going to actually integrate of 1 plus the derivative of the function squared, and then we're going to square root it, and that's when we integrate. So let me repeat. This is going to involve several steps. First off, take the derivative of the function, check. Second off, square, check. Add 1, check. Square root it, check. Then integrate. Wow, lots of steps. So let's start off with a very simple example. Let's go back to example number 2. In example number 2, we were finding the length of a straight line, y equals 3x minus 1, on the interval 0, 4. What I'm going to do is I'm going to do the exact same kind of thing, only I'm going to apply my new formula, okay? So I'm going to use arc length this time to determine the length of y equals 3x minus 1 on 0, 4. Now, the question is this curve, is this y equals 3x minus 1 a rectifiable curve? Is it both continuous and differentiable? And the answer is yes. Yes to both. So what I'm going to do first, I'm going to take f of x equals 3x minus 1. And the first thing I'm going to do, again, is take its derivative. I want to take the derivative of it. Now, this is an easy one to take the derivative of. Remember, derivative of constants just disappear. 3x is going to have a derivative of just plain 3. So that right now is my derivative. Okay, so now what I'm going to do from here is I'm going to square it. So I'm going to take the derivative of f and I'm going to square it. Now 3 squared is 9. So not a particularly difficult thing to figure out. So once I've got this 9, I'm ready to do the next part. So what I'm going to do is I'm going to take 1 plus the derivative of f of x squared. So that means I'm going to go 1 plus 9, which gives me 10. Next step, square root it. So here's where I get into almost the end step. So the square root of 1 plus f prime of x squared is going to give me right now the square root of 10. Now let me repeat. This is a pretty straightforward, this is a very easy example compared to what we will do in a second. The last thing that I need to do at this point is integrate. Now the interval that I'm using is from 0 to 4. So I'm going to write 0 to 4. And the other thing that I need to do, remember, is we're taking the square root of 10 in terms of x, okay? So what I'm going to do, again, this is a constant. I can just take it out. So I'm going to do the square root of 10 times the integral from 0 to 4 of really just a 1 dx. So that's just going to turn into an x. And we're going to evaluate from 0 to 4. So that means I'm going to do the square root of 10 times 4 minus 0, which is, well, just 4. So I'm going to end up with 4 square roots of 10, which is, oh wait, the same answer that I had way back in that other example, example number 2. And so that's actually the really cool thing is, in this case, even though this was a pretty straightforward function, I can now see the steps clearly of what I need to do and still get the same answer as if I were just calculating distance. Now, I know you're probably sitting there saying, but Mr. Harold, that other way was so much easier. But again, let me repeat, that's not going to work for every function. But this, we had a straightforward, nice, pretty example that gave us the same answer we had before. So, I'm getting ready to do a more complicated example. Be back with you in a second.